Okay, start off. Guess what? There was a really big earthquake today. This is like 3 hours ago. Right there. That's Indonesia. Indonesia is a hot spot for earthquake activity. You could see that it was a 7.8. Okay, when you get these kinds of earthquakes in developing countries like Indonesia, people die. A lot of people die. Okay, there are a lot of houses made out of sticks and cardboard and tin. Those houses collapse. If there's a tsunami, which I don't think there was with this one, they have nowhere to go. There's no transportation to get to higher ground, so a lot of bad things happen. But so that was a pretty big one today. Just this morning, there was a 5.0 near Chile. This is right in the area where the biggest earthquake in history happened. That was that 9.5 I was telling you about. So just an interesting factoid that logarithms were used again. There you go. Okay. So we're studying common logs. Most of the logarithms we've done so far have been of this kind of flavor. I gave you a log with a base of 2. Fairly straightforward to solve that, right? What would the answer be here? 4. Yeah, these are right. We've also looked at common logs. Remember, that's a base 10, but I'm not going to write it. It's just a log. And this you could put in your calculator, right? What's the log of 25? Anybody?
1.3979.
Three's enough. So the question of the day is this: how would I deal with something like this? Not to. Why is it not to? Right. So we can't really use this method, right? Nor can we throw it in a calculator because it's not a common log base 10. Okay, so we have something called the change base formula. Basically it changes it to a common log. So this one becomes common log 10 divided by log 1. That you can put in your calculator, right? Anybody?
1.1.
So the change of base formula helps you calculate these values. And again, in the past, before calculators, we had tables. It would tell us what that number was and what that number was, and you'd have to actually divide it by hand. But I'm not that old. Go ahead and work this one.
Oh, that's one.
What do you get? What was this part of it? What did you type in? So change the base formula, what did you put? And you got what? There's a change base formula.
pretty straightforward. This one goes on the top, that one goes on the bottom. I have seen this so many times that I have to say something. Is this correct? Why not? No, it's because the teacher like baited you for it.
And because it's just being long in parentheses and.
Yeah, this. Those are equivalent. This is that logarithm property. Please do not make this error. Okay, so that's a no-no. We'll make the L agree. It's been known to happen a few times. It's very rare. Okay, let's look at some equations. Algebraic and graph. Okay, here we go. Chemistry nerds. I have a pH of 6.7. Common log. 1 over, remember, the concentration of hydrogen ions. What is the concentration of hydrogen ions in that solution? The pH is 6.7. How do you solve that? Wow. We're being very profound today. How do I get rid of logs? Your book, I hate the way your book addresses this, but I'm going to address it because it's going to come up in your work. The book will say this. If I take the anti-log, right? I had never heard of it until I looked at this book. Oh, that's funny. Sure, I give you that one. Why do they use the anti-log? Supposedly they're inverses, right? So these would cancel. But what is the anti-log? Is there an anti-log button on your calculator? No. It's an exponential, right? So if we're teaching inverses properly, what we should do is change that to an exponential. Okay, 10 and 6.7 equals 1 over h plus, right? Is that right? I think so. Now we can solve this equation. And there you go. If, so you know what I did here, right? You good with that? Multiplied by hydrogens, divided by the exponential. If you're writing this as a scientific notation, which a lot of times you will, remember that exponent's on the bottom, so it becomes a negative. There's your concentration of hydrogen ions. Okay. So, yuck, right? Okay, just change it to an exponential. It's much easier and much cleaner. We can use exponentials. But this will come up here. Just know that anti-log is the exponential with the basic. Okay. All right, let's look at some others. How about solve? That. We're going to use logs to solve an exponential. So
would you put it in log?
81 equals 3.
Okay, that's one way to do it. So 3x equals log base 6, 81, right? Now, change the base formula because we have a funny log. 81 is not a power of 6. So it is correct. It's 3 to the 4th. That doesn't help us, does it? You need a 6 to the something here to make it easy. So you have to use the change of base. What'd you get? So this is gonna be,
2.45.
ooh, you were very close. And then x is what, point?
672.
Thanks for that. Did you divide?
You should divide by 3.
I forgot.
Yeah, that does affect things. So, there you go. The other way to do this, okay, it's the same method. It's just a different way of thinking about it. You can also write it like this. So you've just done the log base 6 each side. And these cancel, so what you end up with is insane. It's longer, yes, but some, it just helps some people sometimes. So, there you go, another option, right? Changing it to exponentials is usually faster. Or changing it to a log. Okay. What about, so does that answer?
No.
You had a question on which one?
16.
16. Let's see if there's a, oh, that's right, that's not. Okay. See if I can find an equivalent. It's on a piece of paper, it's ink, it doesn't have feelings. There you go. I don't see an equivalent. I gotta take a risk and make one up. This is not gonna end well. I am not gonna do 16 for you.
Okay, I got it.
Quit trying to get out of it.
Got an example for you.
16 has a root in it. It's kind of ugly.
Just a little.
Um,
Oh, my 16 already.
oh man, this is probably gonna end very bad, but
8.
whatever. Okay.
How about 4 to the power of 2x minus 7.
Okay. This is an ugly one. Right, you're gonna run into something like this on number 16. Yeah, wow. Right. Okay, so we're gonna deal with roots here. What would you do? Cube both sides? Yeah, okay, that's an option. Let's try it. So we end up with 4 to the 3x minus 3. You have to multiply those. Yeah. And this would be 9 times 2 to the x plus 1. Ooh, that's a lot better. Oh, how about that? Yeah. Because I can multiply. I can math. That's very nice. Like I said yesterday, keep an eye on me. Today's a much better day. Okay, now what?
Now. X on
This is where that second method I showed you is gonna be handy. So log base 4. That and all in there. The process of getting rid of the junk here. This is 3x minus 3. I'm gonna deal with that. Say wave my hand and it's gone.
It worked.
What does that mean? Problem with logs. Split them. This is a decimal, right? Yeah. So change in base formula, what is that decimal? Or it's not a decimal. Well, it's, yeah, it is. Log 27 divided by log 4. Okay. How do I deal with that? I got lucky and this is actually gonna work out. Can you make this a power of 4? 2 squared is 4, but it needs to be 4 to the sun power. Damn. Hear that? Okay, we're gonna change this 4 to the 1/2 power. Square root of 4 is 2, correct? So I'm now manipulating my logs to get a nice pretty. So those will actually cancel out. And I got lucky because I made this up. Whew, so bullet dodge. Okay. Subtract this over, right? We get 3x minus 5.377 equals 1/2 x. That you can solve, right? Just a simple linear. You just want to see me screw it up. Say what? You asked for it.
Yes.
Blame it on me.
Not this problem.
Okay, subtract 0.5, and then I'm gonna subtract 3x, so. And now divide, and we get the final answer after a page of work. 2. Is that what you said?
No.
That's the hard problem. Am I gonna throw that on the test? No, I'm not. Honestly, I wouldn't even see that on an AP calculus. Okay. But they always throw a hard problem on this side, so there you go. Okay. Hey, you okay with this? There's a lot of What do I have and what can I do to break it up? I'm using all the logarithm properties. The last one I want to look at.
Wait.
Okay. I will wait. There's so much writing, it takes you 10 minutes to copy. What'd you get? Pretty sure. Yeah, I think you're probably right. What's
The one on the first line is on to Mr. Evans.
one on the first line?
Yeah.
Dude.
I've been meaning to tell you that. Mr. Arthur, have I not been calling your name? For like
She
the
must be
past
whispering
3
it
times.
because like.
Where? Right, where did we go wrong? 'Cause I was trusting them.
Yeah,
That was my first mistake.
it was.
Say when.
I'm
No,
not, we don't.
last slide.
Answer.
Here?
That last slide, she was talking about that slide.
What's the answer? 2.350. Okay, I'm not trusting you. Shut up. What's the answer?
350. If you round it, it's 351 because there's an 8.
There you go.
I showed him some last time and he said I'm not going to. Lie.
Oh, what the heck?
It's not 1.15. It's 1.43.
I didn't do that one, so you can't do that. I didn't.
I'm gonna start throwing stuff. You waited an awful long time.
Yeah.
Okay. Can we move on now?
Bless you.
No.
Aw.
Last one. This is solved by graphing. Yep. If I graph this by hand, is it gonna be accurate? No, it's not. This is a calculator problem. So we graph both equations and find their intersection. Okay, so 5 to the x is it plus 1 or minus 1? Be quiet, I don't trust you. And 2 to the power of x.
-3.
Shut up. That one I know is right. Okay, so we graph both equations. And, oh, my window is. Zoom, standard, or zoom fit. And you can see where they intersect. Yeah. So calculate the second trace. We want an intersection. Remember, you have to select your first curve and your second one, making sure the equations are right. And then you get a guess. I'm gonna guess it's right there. And there's your intersection. The 1.756 is your x and 3.378 is your y value. Okay. I think you can handle those. Good to go? No. Dude. What? No.
It's more than just mathematics.
Okay. Oh, we're done? Any questions for the good of the order? Okay, good, we're done. You have 15 minutes to work on your assignment. Hopefully you get it done. Okay, I'm gonna turn the video off. Record our conversations.
Oh, you deal so that you say